Hi, and welcome to my video on the introduction to right triangle trigonometry. This is the first unit on trigonometry, and it's right triangles. There are other units called the unit circle and special angles, etc., etc., and the area of a triangle, etc., etc. But right now, I'm just going to do the right triangular trigonometry as right angles. Note, all triangles in this section will be right triangles, a right angle. Trig is the study of the relationship between the angles and the sides of a triangle. So we're going to look at that relationship now. Notice I have a triangle divided up into sections, but as you can see, there's 4 and 4 and 4. The height is 3, 6, and 9. If I look at each triangle, then this angle A, right here, is in all 3 triangles. And the right angle at B is right here. The right angle at C is right here. The right angle at D is here. So I have 3 separate triangles. So therefore the first triangle is as a side of 4 and a side of 3. The second triangle ACF, AC is 4 plus 4 is 8, and FC is 6. And the third triangle ADE has 4, 4, and 4, which is 12, and has a height of 9. What I'm going to do now is work out the hypotenuse in each of these right triangles. So here I go. So C squared is A squared plus B squared. And C is the hypotenuse in this triangle opposite the right angle. So C squared is 4 squared plus 3 squared. That's 16 and 9. So C squared is 25. So C is the square root of 25. So C is 5. So this side is 5. Now I'm going to work out the Pythagorean property again for this triangle. And we have C squared is A squared plus B squared. Again, this is your C. I'm going to find that value. So C squared is 8 squared plus 6 squared. And 8 squared, 8 8s are 64. 6 squared is 36. That works out to be C squared is 100. C is the square root of 100. So C is 10 in this triangle. The hypotenuse is 10. And the third triangle, again, this is the hypotenuse opposite the right angle. So let's work out the Pythagorean here. C squared is A squared plus B squared. Notice C is the hypotenuse. A and B are the legs. So C squared is equal to 12 squared plus 9 squared. 12 and 9 squared. 12 squared is 144. 9 squared, 9 times 9 is 81. That adds up to be 225. So let's go up here. So C squared is equal to 225, which is what I have down here. So C is the square root of 225. So C is 15. So let's put 15. So I worked out the Pythagorean theorem to get the length of the hypotenuse of each triangle. Now, did you notice that in similar triangles, if two angles are equal, then the triangles are similar. So notice angle A is the same in each of these triangles as a common angle up here. And all of these are right angles. So all of these triangles are similar. So triangle ABG is similar to ACF. Notice that A goes with A, B goes with C, so therefore G got to go with F. And triangle ADE. So all these triangles are similar to each other. Based on that, let's look at the ratios that we're going to find here based on the numbers that we worked out. complete each ratio. So GB is 3, AB is 4, FC is 6, and AC is 8, ED is 9, and AD is 12. If you notice that 6 over 8 reduces to 3 over 4 by dividing by 2. 9 over 12 reduces to 3 over 4 by dividing by 3. So notice that these sides have all the same ratios because the triangles are similar. And let's look at more sides. GB is 3 over AG, which is 5, and FC is 6 over AF, which is 10, and ED is 9 over AE, which is 15. Again, notice that 6 over 10 reduces to 3 over 5. 9 over 15 divided by 3 reduces to 3 over 5. Again, the relationship between this side and the hypotenuse is the same ratio. And another set of ratios, what about AB to AG? AB is 4 to AG, which is 5. So AB is the same, corresponding to AC, which is 8, and AF is 10, and AD is 12, and AE is 15. So notice we picked this side here with the hypotenuse, this side with the hypotenuse, this side with the hypotenuse in terms of this angle A. So 8 over 10 reduces, divided by 2, reduces to 4 over 5. And 12 over 15 reduces to 4 over 5 because you divide by 3. So notice all these ratios are the same because we're dealing with similar triangles. And if you notice that this triangle right here is twice this one. 5, 2 times 5 is 10, 2 times 3 is 6, 2 times 4 is 8. And this triangle right here is 3 times larger than this one. 3 times 5 is 15, 3 times 3 is 9, 3 times 4 is 12. So what I'm trying to show you here, that if you have similar triangles, the ratios are going to be the same to the corresponding sides. We'll use that again later in the math, but keep that in mind. Okay, let's start some ideas in the trig now, which you know some of this already, but I just want to make sure I have it reviewed. We have a triangle ACB, and notice it's a right triangle with a right angle at C. Normally when we name a triangle with the sides, this side is AB, but we use a small c, small letter opposite the angle. This side here is A, small a, opposite angle A. And this side here is a B, opposite angle B. So the letter that the angle is normally named with a large letter, the side opposite that is a small letter. In this case, I'm using the small letters. In triangle ABC, the hypotenuse is C, because the hypotenuse is opposite the right angle. So the hypotenuse is in the right triangle is always opposite the right angle. I always look for my hypotenuse first. And the legs are the other two. A and B are the legs of the right triangle. In relation to an acute angle, opposite and adjacent sides are the legs. So the acute angle in this triangle is A. So these are the legs, A and B, opposite and adjacent. This is an acute angle at B. So the opposite and adjacent are B and A, etc. So we're looking at the acute angles. We're not looking at the right angle. We'll see that as we go. In relation to angle B. Angle B is the acute angle. Remember, if this is a 90-degree angle, these two angles have to be less than 90, so these two angles are acute. So in relation to angle B, here's angle B right here. If this is angle B, then which side is opposite angle B is across from? So that's small b. In relation to, right here, gotta go. I went down here. I rubbed it out, sorry. In relation to angle B, the adjacent side is alongside of, so it's A. Now, that's for angle B. That's opposite, that's adjacent. What about in relation to angle A? In relation to angle A, the opposite side is across from, so go on over, is A. And the adjacent side to angle A is B. So think about, if you think about an angle, here's angle B. Opposite is across from, adjacent is alongside of. And that's always the hypotenuse. Let's continue. Practice complete with a single letter. So you pause the video, work out the answers, and press play it back to see if you're right. In this triangle, notice angle PQT. So the small letter is T opposite the angle. The small q is the letter opposite angle Q. And small p is opposite angle P. In relation to angle P, here's angle P. The opposite side is across from P. In relation to angle P, the adjacent side is T. And the hypotenuse is Q, opposite the right angle, Q. In relation to angle T, now we're looking at angle T, the acute angle. The opposite side for angle T is T. The adjacent side for angle T is P. And don't forget, the hypotenuse is the hypotenuse. It's the two legs that are the adjacent and opposite. Number 2, we have a triangle, and we have it named, but I just have different letters here now, which makes no difference. In this triangle, the hypotenuse is D across from the right angle. In relation to angle F, the opposite side is V, and the adjacent side is W. So hopefully everything is going okay. We have to make sure we have to know that. That's why I'm taking time to review it. And we're on our last page. Some more examples and practice. Complete each ratio. Now, we have a triangle, a right angle at F, and we have an X, an F, and a Y. I could have marked that a W, but it doesn't make any difference. In relation to angle W, in relation to this angle right here, the opposite, now what I do when I look at a triangle, this is the angle I'm talking about. So if I'm talking about this angle, then I put an H for hypotenuse, I put an O for opposite, and I put an A for adjacent. So in relation to this angle right here, that's opposite, that's adjacent, that's hypotenuse. Now I can fill in these ratios. Opposite is the Y, and the hypotenuse is the X. Adjacent is the F, the hypotenuse is X. Opposite is the Y, and the adjacent is the F. So by marking O, A, and H, you can fill in your ratios very easily. So, if that makes sense, let's practice on these 5. Do one at a time to make sure you're going correct. Don't do them all and then go back and correct them from 1 to 5. Do one and press play and see if you're right. Then if that's right, press play and see if you're right on the second one. So do one at a time. Here we go. Number 1. In relation to this triangle, in relation to angle A. Before we start, this is the better be careful. That's the hypotenuse, H. In relation to angle A, that's opposite. In relation to angle A, that's adjacent. So, in relation to angle A, opposite is T. Hypotenuse is the D. In relation to angle A, adjacent is R. And the hypotenuse is D. In relation to angle A, opposite is T, adjacent is R. Hopefully you're right. If you are, press, work out the second one. Remember, pause the video, work out the answer, and then press play. Here we go, number 2. In relation to this triangle, here's the triangle, right angle here, and we have the sides marked in relation to angle H. So this is angle H. So again, this is the hypotenuse. This is the opposite. And that's the adjacent. So fill in the ratios with the letters. So in relation to angle H, opposite side is V. Hypotenuse is P. Adjacent side is E. Hypotenuse is P. In relation to angle H, opposite is V. Adjacent is E. So it's V over E. If you're correct, work out the next one. Pause the video and play it back. Here we go. In relation to this triangle, here's this triangle we're going to use now in relation to the angle J. So here's the angle J. So I always do the hypotenuse first. So that's the hypotenuse. This is the opposite side. This is the adjacent side. So I do the hypotenuse first. That means the other two are opposites and adjacent in relation to an angle. So it's angle J. So in relation to angle J, opposite is the A over the hypotenuse C. In relation to angle J, the adjacent is the B over hypotenuse C. In relation to angle J, opposite is A over adjacent, opposite over adjacent. Now, if you're doing opposite, you could also write OPP, HYP, ADJ. So you won't get mixed up. HYP, opposite OPP. If you do that, OPP, HYP, ADJ, then you won't get mixed up with your letters. Okay, number 4. We have a triangle which is 10, 8, and 6 for the sides with a right angle. Notice every triangle is a right triangle. This is right triangular trig. We're going to do trig later in later units when they're not right triangles, but we'll get there later in a higher grade. In relation to angle K, this is angle K. So now, this is the hypotenuse, HYP. In relation to angle K, this is the opposite side. In relation to angle K, this is the adjacent side. So, in relation to angle K, opposite is the 6 over the hypotenuse, which is 10. Notice 6 over 10 reduces to 3 over 5 by dividing by 2. The adjacent side is 8 over the hypotenuse, which is 10. And again, 8 over 10 reduces to 4 over 5 by dividing by 2. And in relation to angle K, opposite is 6 over 8, which is divided by 2 is 3 over 4. Always reduce the fractions when you're working. When you have fractions that can reduce, always simplify, reduce them down. Number 5, in relation to angle N. Here's a triangle, here's a right angle, here's angle N. So 5 is the H hypotenuse, 3 is the opposite, and 4 is the adjacent in relation to angle N. So opposite is 3 over hypotenuse 5. Adjacent is 4 over hypotenuse 5. Opposite over adjacent is 3 over 4. But I don't know if you notice, look at these two triangles. These two triangles, that angle equals that angle. Angle K equals angle N. These two triangles are similar by AA similarity. Therefore, their proportions are going to be in the same ratios. So notice, because two triangles are similar, in terms of the acute angle, the opposite of the hypotenuse in both of these triangles, both reduce to 3 over 5. The adjacent over the hypotenuse is 4 over 5. And the opposite over adjacent is 3 over 4. Notice, because the triangles are similar, the opposite to the hypotenuse, the adjacent to the hypotenuse, the opposite to the adjacent will become the same ratios when they're similar. So that's the review to start it all off. Picking out opposite, adjacent, and hypotenuse, very important in trig. If you like my video, click the like button, the subscribe button, the notification bell. Visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel, which is Math Fully Explained. Thank you for viewing my video. Bye-bye.